Hi, engineering space. Let's start over. Hi, engineering space cadet. So today we're going to be talking about object-oriented programming. And object-oriented programming has four main components that most people who learn object-oriented programming do know. But for those who are not familiar, those four components are polymorphism, abstraction, encapsulation, and inheritance. So today's lesson, we're going to go through each of these different topics, explaining the very basics of object-oriented programming, why you may use them, why you may not use them, and also how they're used in Python. Okay, so let's get started. So the first one we're going to go into is inheritance. Now, in my last video, we went over classes. Classes are kind of the basis of inheritance. We want to take something from one class and then move those features into another class. So we don't have to recreate those methods or functions again. So we're going to create one class, and this class we're going to call animal. Now, this is a very common way that people kind of show inheritance, and I know why. But for my purposes, maybe I don't want to do animal. Maybe we'll do foods. So we'll do foods, and we'll create our very basic init method. So we're initializing our class, and inside of here, what we could do is we could pass in certain other features such as name of the food. Yeah, name of the food and maybe food group. Okay. So here we're going to start off by using our init method, and we're going to add some self here. So we'll have a self dot name, and we're equal that to name, and then we'll have a self dot food group, and we'll just equal that to food group. Okay. So we're gonna make a new method, and we're gonna call this method name and food group. Okay, so for here, we can just have this method, and we'll just use self. And what we'll do is we'll print a statement that says, basically, using this f string, the name of this food is, and then we'll fill in this with a self dot name, and it belongs to food group and we'll add this in as well, and this will be self dot food group. Okay, so we have this method, and we just kind of have these features. So we can add another one that we define, and we'll call this get name. Again, you don't have to get these getters and setters, but it's something that comes from other programming languages that you may be familiar with. So if you are someone who is used to getters and setters, like you're using in Java, or you're trying to encapsulate or set some things, which encapsulation is another feature we're going to go through in this, you may use this get or set method. So this way, we're not going to directly just call it and just get self dot whatever food object. We're just going to return it here, just make it easier on ourselves. Self dot name, and then we're just going to have one extra one as define get food group. And here we're just going to do the same thing. We're just going to return a self dot food group. Okay, so we have this food class that already has a bunch of different methods that we could use, right? So if we called in a food class into another class, we could probably just use this in a different way. Well, that's the entire idea of inheritance, where we can take these features from class and we can pass these features directly in to another class and just have access to those features. So we're going to create another class. We're going to call this class pizza. And one way that we can do with like inheritance in Python is we can just call in directly. We use these parentheses and we call in the class that we're trying to inherit from, right? So then we can make another def and we can create our own init, underscore init self. And then from here, we're going to use this keyword called super. And we're going to use, actually, we're going to still need these two features from food, which is going to be name. And also we're going to need food group. So that's not too crazy. Since we have one class that already has these, we can just call it back in again. We're going to use super and then dot underscore init, pass it in name for name. And then we're going to pass in food group for food group. So this super is just calling into the class, like this parent class. And we'll just use this parent class is init, where it passes in the name, the food group, and we'll be able to use all these features from this food group. Okay, so for an example, we only have what you see here. We're only inheriting from food and only calling in the super method. So if I make a new object, so we're going to call this pizza, and our pizza object is going to be used here, and we're going to pass into our pizza object a name. So we're going to call this one pepperoni. And the food group would be, let's just say, for example, in this particular scenario, we're going to call this one grains. Okay, so if I use pizza, you can see that pizza doesn't actually have any other methods inside of it. I just wrote the super, this init, but if I use this, you can see I have access to all the other methods that it's using. So if I have name and food group, and then I have pizza, where I can just print pizza dot name, and then I can also print pizza, or let's just use the method get name, and then we'll also use the method get food group. And if we run this right here, you can see that it takes from this other class that we didn't directly rewrite any of these methods for food. Since food has name and food group, get name and get food group, we just use those methods directly into this other class. By just inheriting from this class, we're able to use all the methods that come from food. Now we can make our own methods within pizza, but that's going to be a whole different thing. But for now, this is just showing you how inheritance can work in Python. So now we're going to move on to encapsulation. So we're going to comment this out just so this doesn't run twice whenever we start calling in the next thing. And this is going to be encapsulation. So here's the thing. Let's say, for example, you have some data, and there is some publicly available data that maybe you want to be able to pass directly to a user. And you say, hey, this is totally fine. You can use this all you want to. This data can be manipulated, it can be mutable, and that's totally fine. Let's say, for example, you don't want the user to be able to edit the data that you're either putting in or you're receiving, unless you want them to be able to adjust it in a different way. Only with your own methods can they change this information without directly needing to call it. Okay. So if that was confusing, I'll kind of write the example and then explain a little bit more what I meant by that. So we're going to call in a class, and this class is going to be called, let's just have fun. We're doing a food theme. So let's just do something more specific. Yeah, we can just do food again. This is totally fine. So we're going to have another food group. We're going to have another food class. And we're going to have this init, right? Now, right now, we know what kind of foods and food groups that we could have, right? We could have dairy, we could have grains, we could have vegetables, we have fats, we could have meats, and we can just put all of these things in fruits, vegetables, all this stuff into some way. So let's just say, for example, here we wanted to have self dot grains. And we're just going to set this self dot grains to bread, right? This is totally fine. So if I make a new instance of this class, let's just take that back real quick. If I make an instance of food, so we're going to call this food 1, and we call in the food class. Here, if I have food 1 dot grains, I can directly access that, so I can just print it directly, right? This would be kind of more along the lines of a public variable. You see, I can directly access it, no problem at all. And you can see that even whenever I just do this dot here, dot grains, you can see that that variable is just already available. And that's totally fine. There's no problem with that. If that's kind of what you want, people are like, okay, fine, no problem. However, let's say, for example, you want to make this a little less apparent. So we could create something like this where we have self dot, let's go fruits, and we're going to equal that self dot fruits, which we don't need these parentheses for bread. We have self dot fruits, and we're going to take the self dot fruits, and we're going to have a apple, because I like apples. One of my favorite fruits. Okay, so we have self dot fruits. Now this is just as available as this other one. Now Python doesn't have a way to completely restrict someone accessing these variables, but we can make it a little bit more difficult for someone to access these variables directly. So what we're going to do is we're going to use something called protected. Now we're going to have this protected attribute. And yeah, I should be referring to them as attributes if I should. So we have this protected attribute for fruits. And if we do the same thing, you can probably still see it, right? So we have food 1, and then dot. You see it doesn't pop up immediately here, but if we do call it in underscore, and then we type in fruits, we still have access to it, right? But it's not so apparent. It's not as easy just to see it here whenever we just call it in. So it's a protected attribute. So as long as it's not publicly facing here, not a problem. It's protected. Now, let's say, for example, we have our last one here, which we're going to call self dot meat. We're going to equal this meat to be steak. Now, we have one that's like a public attribute that anyone can access easily. Fruits, that's more protected. And then we're going to have this one here with a double underscore to indicate that this is a private attribute, where this one should not be as easy to access as the other two, right? So if we have this one, we need an underscore for protected, and we can still call it fruits. And then we can do the same thing here for food 1. And then you have this double under. And you probably shouldn't be able to see it here, but we can still call it in technically. So meat. Now you see nothing's popping up, as it shouldn't, but I think we still see no attribute, meat. So you can see right here the difference between like a private and protected method. Protected method, you can still kind of call it in, but a private method, you're not going to be able to. So let's say, for example, we create a method to call this where we have define get meat, and we use the self, and we're going to return self dot double underscore meat, and then we're going to instead just print that get meat, and this should give us access to that meat. The reason that you want to do this is sometimes you don't want the data to be as easily accessible. So we're encapsulating or surrounding this data in a way that we can take certain methods that are, or certain attributes that are public, and hide those. We can have protected methods that are a little bit harder to see but still accessible. And then we have these private attributes. And these just allow us to have something that is so much harder to access and can only be accessed indirectly. So indirectly just means you can have a method that can be called to add or change or something like that. So let's say, for example, we want to change the meat, and we define one that says set underscore meat. So we're going to set the meat, and then we're going to pass in a argument or a parameter. And the parameter that we have here is the name of a new meat. So meat underscore name. And what we're going to do is we're going to not return anything, but we're going to set this self that double underscore meat equal to meat name. So now when we have this setter, we can have print food. We're going to get meat food one dot set meat, and we're going to set the meat name to something different like sausage. I'm so bad at spelling. Sausage. Is that spelled right? I don't know if that's spelled right. You know what? I'm gonna do an easier meat. So the meat I'm gonna do instead is chicken, because I can't spell. So here we're gonna have grains, fruits, get meat, set meat. And then from here again, since we already set the meat one time, we're going to use food one dot get meat. And we're going to get this meat again. And this time it should go from steak to chicken. And you should see 4 outputs as one for our publicly available attribute, our protected attribute, and also our protected or private attribute. So we're just going to label these just so it makes it easier if you're looking back at it later. This one is a public attribute. This one is protected. And this one right here is private attribute. Now you can do the same thing with methods. You can have private methods, protected methods, and also public methods. Most of these methods right here, at least these two right here, are public methods. So yeah, we're going to run these real quick. And as you can see right here, this is not printing anything. It's just running. So it's not going to return anything. So all you're going to see is that none. So as you can see it right here, we're going to go from bread, apple, steak. There is a none because I was printing out something that didn't actually like have an output. And since it didn't have an output, it wasn't going to return anything. Now I could here, pass in this right here, just say, hey, we're passing none, just as something to return to the user to let them know that, hey, this is not supposed to pass anything. So just set it and forget it. But for now, this is not that important. We don't need to alert the users at the moment. This is just learning about OOP. Okay, so for here, we can just run it. And as you can see, it takes this protected, or this takes this private method, or private attribute. It takes this private attribute and turns it into, and it accesses it through this set meat method and returns it to chicken. So you can see bread, apple, steak, and chicken. So that's the idea of encapsulation. Sorry, I made a couple mistakes there. We're gonna move on. We're just gonna keep rolling. Okay, so abstraction. So this is one of the ones that is kind of the funnest, but also can be a little bit complicated to understand. There are reasons that we do it, and I can explain some of those reasons, but we're just gonna get started with abstraction. Hopefully it's not that confusing. Okay, so let's say, for example, we want to create a basic class, right? And we want to change this class based on whatever child class we're using. So we want some methods to be kind of available already, right? And these might be just things that might come across all the cases. So if we had an animal class, we might want to have a species or a return get species, something like that, right? So what we could do is we can import a ABC method or a class, or from ABC import ABC and abstract method. Okay. So from here, we're going to create an abstract class and an abstract methods for that class. Now, these are required by your base class to be filled in and called into your abstract class. So if we make a base class and we're going to call this one, we're going to do the same thing. We're going to do like an animal class. So we're going to call a class, and we're going to call this an animal class. And for here, we're going to import ABC, which is its own class, which is for just for abstraction, just for abstracting the class and making this into an abstract class. And then we're going to do the same thing here. We don't need necessarily a init here because we're not actually going to be running anything here unless we absolutely were. So we don't actually need this, but here we're going to start creating methods that we want to use. So we're going to call this name. And what this will do is if we pass in, let's just do a name for this one here. And let's just say, for example, we want to have a self dot, and we're going to have this as a private name. So we're going to have this as name, so that equal to name. Then here, we're going to create a decorator called abstract method. And what this will do is we'll return the name. So the self dot name of the animal. And maybe we want other things like an abstract method for a species. So for a species, we may have self, and we can just pass in a couple different things. So we can do species too. No, we don't have to do it this way. Species. We can actually just have this as a variable. Species, if I can spell, which I can't. We can have different species as like a variable that we pass into species. But for this purpose, we're just going to create these abstract methods that will just take this and return our species and return the name of the animal. Okay, so we will take a return, and then it'll be a self dot private species, and then we'll have one more, and we'll create an abstract method. And in this abstract method, we'll create define species underscore and name. Okay, so we'll have this as return. Now what I'm going to do is I'm going to actually return. Now I don't actually need to do any of this, to be honest. I don't need these returns. And actually, instead of doing this, making it more complicated than it needs to be, we're just going to do a pass, returning nothing. Do pass, return nothing, and then here we're going to return nothing. So we don't actually need if anything inside these abstract methods. There's going to be methods that we're going to call if we need them, which means here we can have this as well. And we can just have this as a pass. This should be completely fine. So now we're going to create a new class based off the animal. And we're going to call this class mammal. Inside of mammal class, we're going to call an animal class. And what we're going to do, essentially, is the same thing. We're going to be able to use all these methods from here. And Control C. I'm going to use all these methods, but I'm actually going to fill these in with information. So for here, instead of having these abstract methods, which we don't need, we're going to call on this, and we're going to have a return self dot underscore underscore name. And you can see it doesn't exist right now. And self underscore like this, name is equal to name, and then self dot species is equal to species, right? And then we have this, and then we have return self dot species. And this last method, what we're going to do is we're going to print with an F string the name of this animal is, and then we'll bring in our self.name right here, and then the species is self.species. Okay. So we're just accessing them indirectly, and we can just remove these abstract methods because these are no longer abstract, correct? So here we had this abstract class up here, and I think that this may be a slight mistake because I'm not calling it the super method, but we're going to check that out and just see if it is. And we're just going to call this, and since it's inheriting from animal, all these methods need to have the same name. And if you try to run this without having the methods with the same name, it's going to throw up an error for you. So we're going to call in A1, which is equal to our animal class, and we're going to pass in the name. And we're actually not going to do the name. We're going to do mammal class. And the name for mammal class is going to be a dog. And I guess we'll have the name be like, what's a good dog name? Let's see. Lassie? Yeah, from the movie. And then we'll have the species be named dog. We could do the scientific name, but we're not going to do that for this point. At this point, so we're just going to have this here, and we can have this name method here. So we're going to print name, print a1.species method, and then we're also just going to run a1.species and name. So we're going to run this, and as you can see, ooh, there is something with going on with the bread here. Yeah, I forgot to take out the food class here. So we're just gonna go all the way up here, and we're gonna comment this out. So you can see right here, I can use all these methods, and you're like, okay, so that's fine. There's no problem with that. So let's just say, for example, I comment out this name. And I just return self._name, right? No problem. Essentially, I'm not doing anything. I'm not breaking it because I'm still using this name. I'm just forgetting the method and just replacing it with the private attribute. Okay, so let's run the code again. And as you see, there's a problem, an error that throws. You can instantiate an abstract mammal without implementing for abstract method name. So that's essentially just saying that because I didn't define this name here, I can't actually use this abstracted class for animal or for mammal. So anytime I'm making a new class, I can use the abstracted animal, but all the methods in there have to be the same, but we can add special methods to it that we don't actually that need to be an animal class. We just have some basics that we want to have for every time we make a new class based off animal. So if we want to do something like amphibian class, or we want to do something like bird class or fish class or something like that, we would need to call in our animal as the parent class. And as the child class animal, we just need to have the same base classes. That's what the purpose of abstraction is. You can have a lot of things abstracted out and just have the implementation themselves be done in the other classes. Okay, so polymorphism is very fun. I didn't want to go over this one first because I think that if I went over polymorphism first, it'd be a little bit more confusing than it actually is. So, essentially, we can create polymorphism in the way that we would also have the idea of duck typing, which with duck typing, it's essentially like if it looks like a duck and it quacks like a duck, then essentially it's a duck, right? So if we create a class, we're gonna call this class duck. Okay. Now we're not gonna do any inheritance. We're not gonna do any um, abstraction. We're not gonna do any inheritance, abstraction, or encapsulation. We're just gonna create a duck class. Now for here, we're gonna create a net. So we're gonna define this, and we're gonna create a net, and we're gonna give this duck a name, right? So we're passing a name, and basically we're gonna have a self dot name is equal to name. Now we don't have to do this, it's just for me, but I just think it shows concept. So at the same time I create this duck class, I'm going to create another class as well, and we're going to call this chicken. Chicken class. So class, and then we have a chicken class. And we can just essentially define this as this net and name, and we'll just have a self dot name. Now we'll create one class and we're gonna call it speaks, and just keep a self, and what we'll do is we'll print out the and create an f string here, the self.name says quack. Okay, and then we can create another one where we have define speak, let's see, quack. What do ducks do that chickens don't do? We can call it walk, and we just print here with this f string the, let's see, duck named self that name waddles. Okay, and then we can do the same thing here. We're just going to copy these two methods here, Control C, and we can say that the chicken named whatever name Clucks. Let's see, Clucks, and the chicken named walks. Like a chicken. I don't know. I don't know how different chickens walk. I could have called this like penguin class, I guess, and just had something a little bit different and just had like penguin slides. But essentially, it doesn't really matter, right? So let's create a method, right? And this method, we're going to call it uh, action, right? Now for here, we can pass in an object, and in this case, we'll have OGB or OBJ, that stands for object, and we're gonna just expect a duck, right? So we're gonna type in for the duck, and then we're going to basically return nothing. And we're just gonna print, and we're just going to have object. We're gonna have object here, and we're gonna have the object speak, and then we're gonna have the object walk. Okay, so it doesn't really matter, but we are kind of just saying that, hey, we're expecting this duck, right? We're expecting a duck class to be passed into action. However, if we create two objects, we're going to call this one duck is equal to our duck object, and we're going to name the duck Daffy, and we're going to name the chicken equal to chicken, and this chicken's name is going to be, what is that chicken's name? Goodness, this is probably the hardest part of programming, is naming things. The chicken, I cannot remember that chicken's name. So we're gonna call him Arnold, because I have no idea what else I would call a chicken. And essentially we're going to call in action. Now you can see that action is expecting a duck, so we can pass in a duck, right? And if we run this, no attribute name. Chicken object has no attribute name. It should. Let's take a look. What are you expecting? Declaration. Name is equal to Arnold. Duck name equals Daffy. I don't think we changed anything crazy. Oh, that's what it was. I'm very silly. Okay. Name. So that's what it is. So we don't actually need this. This is just extra. And this right here, Daffy. So we're gonna call it an action, and you can see. Ooh, yep, gotta comment this back out. I need to get in the habit of commenting this stuff out. And we're gonna go back down here, and we're gonna run the action for duck, and you can see the duck named Daffy quacks. Quack. Ugh. So clearly, grammar is not my strong suit, but I can code, I promise. And we have cluck. It's just cluck. Clucks like this. Sure. You see the duck named Daffy quacks, and the duck named Waddle, and the duck named Daffy waddles, right? Now you can see that these have the same overall like methods: speak and walk, and then chicken's got its own speak and walk. So instead of it just like caring, it's like essentially it does the same thing that the duck does anyways. It walks and it speaks. So whenever you just pass it in, it still works. So since the object speaks or it walks, if it looks like a duck and it walks like a duck, then essentially it's a duck, right? So this is an aspect of polymorphism where you can kind of override these things, or you can write your own methods and your own classes, and as long as they are the same, essentially the same, it can use them and doesn't care. It's like this duck looks the same as this chicken, And if you pass in this object and it speaks and walks, it's basically a duck, even if it's a chicken. So that's the idea of polymorphism. So, yeah, I think that is a very good brief basis for all of the object-oriented ideas. So, yeah, after this, I'm just going to push this code to my GitHub that you can kind of review over later. And I think next time we'll probably get into something a little bit more fun. I think I said that last time, but I wanted to go over object-oriented programming. Okay, thanks for watching. I'll see you next time.